In this lesson, chapter 11, section 9, we're going to be exploring similar solids. So we're going to be talking about similar figures. So on our first slide, we have solids of the same type with equal ratios of corresponding linear measures, such as their heights or their radii. So when I'm talking about the same type of solid, I'm going to be comparing, for example, two rectangular prisms or two cylinders. They have to be the same solid when I'm comparing them. And then we're going to be seeing similar figures. So for example, I could have a tiny little rectangular prism, and then I can have a larger one. And I'm going to check to see if their ratios are the same, then I know that the two figures are similar. So we already saw this in similar polygons and similar triangles. I don't know if you remember when we covered the similar triangles, remember we had those shortcuts. Here we're just going to compare the linear ratios to make sure that they're the same. So that ratio is called the scale factor. And the order that you list the ratio will be important. So whether they tell you to give the scale factor based on small to large or large to small, you need to read. Now, one thing to remember, that any two cubes are always going to be similar. Okay, they may not be congruent, but they will always be similar because we're only comparing one linear ratio. Okay, because all the sides are the same in a cube. Same thing when we compare two spheres. They're always going to be similar because we're only comparing the radii. They're not going to be congruent necessarily, but they will always be similar. Everybody good on this one? Let's try the next slide. It's a theorem, Theorem 11.13. And this is the theorem for similar solids. So if two similar solids have a scale factor of A to B, then their corresponding area ratio is going to be A squared to B squared, and the corresponding volume ratio will be A cubed to B cubed. Let's try the next slide. Everybody good on this one? Okay, next, here's our examples. Are all spheres similar? We just saw this. Yes, they are. Okay, let me jump down to C. Are all cubes similar? We just stated this 2 slides ago. Yes, they are. Now, but as far as are all right cylinders similar, this would be no. And I'm going to show you 2 different examples. This is only sometimes. So let me show you an example of where they would not be similar. All right, so if I were to draw 2 cylinders, I draw a shorter one and then a taller one. And let's say this one has a radius of 3, and let's say this one has a radius of 4, and this one has a height of 5, and this has a height of 7. So for this one, I need to compare the linear ratios. So I can either do radii to radii, so 3 to 4, and it needs to equal height to height, which is 5 to 7. Notice these are not equivalent ratios. Even if I did radii to height, so 3 to 5 and 4 to 7, it's still not the same ratio. So this would be an example where these 2 cylinders are not similar. Now let me show you an example where they would be similar. Let's say I draw a small one here and then another larger one. So let's say I told you the radius was 3. This radius is 6. And then 4 and 8. Does that make sense? So now I can do this two ways. I can either do radius to radius and make sure that it equals height to height. So I can do 3 to 6 and see if it equals 4 to 8. Notice they both simplify to 1/2. So this example, they would be similar. So this is why it's sometimes, notice the word all right cylinders. Now I can also compare ratios. I could do radius of one cylinder to its height and make sure it simplifies to the radius of the height of the other one. So if I take this one, the 3 to 4, and set it equal to this one's 6 to 8, again, these both simplify to 3/4. So either way, whether you do radius to radius equals height to height or radius over height equals radius over height, they need to simplify to the same ratio. Let's try another example. They're giving us, it's a word problem. A picture is not provided. So I'm going to go ahead and draw a picture for myself. So I'm going to draw 2 cones. So this one says it has a radius of 8 and it's got a height of 16. And this one says a radius of 12 with a height of 24. Notice the word respectively here. So this tells me that the 8 goes with the 16 and the 12 with the 24. So it wants me to check to see, are these cones similar? So again, I can decide and check it with radii to radii equals height to height. So 8 over 12. And I'm going to see if it simplifies to the same ratio. 8 over 12 is going to simplify to 2/3, and the same with the 16. So because they both simplify to the same ratio, I would say yes, these are similar. Now, I could also do radii to the height of the red one and set it equal to radii of the height of the blue one. So if I do it this way, it's 8 over 16, 12 over 24. Notice they both reduce to 1/2. Now, if the question also said, what is the scale factor? Then I don't have an option. I have to use radii to radii, height to height. So if it asks you to find the scale factor for these two would be 2/3 or 2 to 3. Now, the theorem that we learned, remember it told you that if you have a scale factor, it's a to b. The area scale factor would be a squared to b squared, and the volume would be a cubed to b cubed.
Miss Corey,
Yes.
is the scale factor always radii over radii and height over height?
Yes. You have to use that proportion or those ratios. Now, you also have to look to see how it's asking it for. So this would have said, from small to big, or it might have said from left to right, state the scale factor. If they would have said, what's the scale factor from the larger cone to the smaller, then it would be 3 to 2. So the scale factor is 2 to 3. My area scale factor is going to be 2 squared to 3 squared. My volume would be 8 to 27. I believe we had questions like this when we did the similar triangles. I know this gave some people a little difficulty. So just remember the theorem. So if you know the scale factor, then you can find the area by squaring that scale factor, and the same with the volume. Okay, we have one more example. Everybody good on this one? Let's try the last example. It says we have 2 similar square pyramids that have base areas of 4 meters squared and 36 meters squared. So again, remember your scale factor is this, which is also going to be the height ratio. So we're going to set it up as we take our area ratio, and it's 4 over 36. So remember, this is really a squared over b squared. My scale factor should be a to b. So what I need to do is square root these, and this becomes 2 to 6, or 1/3. So my scale factor ratio for the heights is 1 to 3. So if they give you an area ratio, you square root it. For, let's say, now for part B, they're telling us the height of the larger. So what I do is I set up a proportion. So I'm going to take 1 over 3. The larger is 27. It matches with the 3. And now I need to find the height of the smaller. So I'm going to cross multiply and now divide. So the height of my smaller pyramid is going to be 9 meters. So you're going to use that scale factor and you're going to set up a proportion. Now, let's say instead, let's say the question said, given the ratio of the volumes, and let's say they told you it was, let me do it the other way, 27 meters cubed and 81 meters cubed. What you would do is, again, remember, and if they ask you to find the height, what you would do is, remember, height would be a to b, area is a squared to b squared, and volume is a cubed to b cubed. So if they give you the volumes, you're going to cube root each number. So this would give you 3 to 4. So just read what they're giving you and then turn them into a scale factor. If they give you area, you square root it. If they give you the volumes, you cube root it, and that would give you a scale factor. And then from there, let's say they gave you like a missing height, then you could go ahead and calculate it. So that is it for 11-9. So you have a test on this a week from today. I will be adding the assignment to Canvas so you can remember to study. So your homework due Friday is the 11-9 assignment. You're also going to be working on the warm-up because, again, Friday's class is kind of short. I'm going to be giving you a homework assignment over the weekend, and it's going to be the test review. And that will be due on Monday. Monday we will review, and then your test is on Wednesday.